Question number 5. The standard method of screening for a disease fails to detect the presence of the disease in 15% of the patient. We have a standard method of screening and the failure rate is around 15%. Okay, so let's write P equal 0.15. Now a new method of screening has been introduced, and to check whether the new method of screening is superior, we are taking a sample of 75%, we are taking a sample of 75 people who have the disease, and we are screening them using the new method. Okay, so let's take n equal to 75, and we want to check if the new method of screening is superior. So what is it that we want to check? We want to check if p is less than 0.15, right? The new method failed to detect presence of the disease in 6 of the patient. So out of 75 patient that we had chosen, 6 of the patient, the new method failed to detect the presence of the disease. So the failure rate using the new method of screening has been observed as 6 divided by 75. That will come out to be 0.08. Now, so the first question is identify the null and the alternative hypothesis, right? We wanted to check whether the new method of screening is superior or not. Okay, so we want to check whether the failure rate is less than 0.15. The correct answer will be option C. H0 P equal 1.15 and HA P less than 0.15. So C is the correct answer. Now the second question is find the p-value of the test. Okay, find the p-value of the test. How do we define the p-value? It is the lowest significance level at which you are rejecting the null. So probability. Okay, before we find the p-value, let's write our test statistic and test. So H0 is p equal 1.15. HA is p less than 0.15. What is the test? Test statistic. Let's take the test statistic to be x bar. The test is going to be reject H0 if x bar is less than C. Now what is the p-value of the test? So the p-value is going to be probability that we reject H0. So we are rejecting H0 when x bar is less than the critical value, and what we had observed the failure rate from the sample to be 0.08. So this x bar should be less than 0.08 given that our p is 0.15. Now p equal, now this is equal to probability x bar minus mu, that is in this case it is p, so 0.15 divided by under root of 0.15 times 0.85 divided by 75, right? And this should be less than equal to 0.08 minus 0.15 divided by 0.15 times 0.85 divided by 75. You know, this becomes capital Z. So this is probability Z less than, once you solve this, 0.08 minus 0.15 divided by square root of 0.15 times 0.85 divided by 75, it becomes minus 1.69, and this is equal to FC of minus 1.69, and this value comes out to be approximately 0.04. So the correct answer, so the p-value of the test is going to be 0.04. Okay. Okay, this is a mistake here. Just remove this. Now coming to the third problem, it says, will you accept or reject the null hypothesis at a significance level of 5%? Okay. Now we just found the p-value of the test. Now we have to check whether we are going to accept or reject the null at a significance level of 0.05. So alpha is 0.05 and the test is this left-sided test, right? We found the p-value to be 0.04. This is our rejection region. Okay, this is our alpha, which is 0.05 for some critical value, say C. Now we found the p-value to be 0.04, that is going to lie which is less than alpha, right? Which is less than alpha. So it lies in the rejection region. So for the significance level alpha equals 0.05, we are going to reject H0. So the correct answer will be reject the null hypothesis.